Hey class, this is Mrs. Hunter. So let's take a look at some titration examples. So example 1, milk of magnesia is a common antacid. 3 molar magnesium hydroxide is used to completely titrate 50 milliliters of stomach acid, which is hydrochloric acid, of an unknown concentration. And we want to know what is the concentration of HCl. So anytime you see something in brackets, that means the concentration of, and we're solving for it in molarity, right? Remember, molarity is moles per liter. So, remember what we've looked at so far. What you're going to know before you do the experiment. You're going to have a solution that you know the molarity of. In our case, that's going to be the 3 molar magnesium hydroxide, okay? So the known solution must be our base, right? Because we can titrate the acid with the base. And the known concentration is 3.0 molar. Your unknown solution is the one whose molarity we're searching for. In this case, that will be hydrochloric acid. And what you're going to know is how much of it you're using in the experiment. So we are titrating 50 milliliters of that stomach acid. You're also going to use an indicator for your virtual labs. I don't think you have much of a choice, but in real life you would look at the indicator chart and we'd be able to figure out which indicator to use. So the chart looks something like this. We're mixing a strong base with a strong acid. They're going to perfectly neutralize each other, which means we'll have a pH of 7. So we want something that changes around 7. So if I look at this, there's probably a couple options we could use. The best one would be phenyl red. It clearly goes from yellow to red right around a pH of 7. So that'll be a good indicator of when we stop adding that base to the acid. So in our case, we're going to use phenyl red. All right, so let's take a look in a little more detail at that diagram that's kind of showing you the lab setup. So you have your burette and it's filled with 3 molar magnesium hydroxide. We have our hydrochloric acid of unknown molarity. We have added the indicator, which is going to be yellow when it's acidic. We're going to know to stop adding base when that indicator, when that solution turns red. So if you look at the after titration, it shows you exactly, right, the difference, how much of that base we had to add in order to neutralize the acid. So to kind of summarize, when the magnesium hydroxide is added, the base neutralizes the acid. The indicator will change to blank when the solution turns blank. Well, the indicator is going to turn a red color when the solution turns basic, which for us just means that the solution, oh, not 9, whoa, is greater than 7. All right, so once you complete the experiment, the real piece that you're gathering in the experiment is how much known solution you've added. Well, I've told you the difference between where we started and where we ended was 11 milliliters. Okay, so this is how much of the magnesium hydroxide was added to that acid in order to neutralize it. So this is the formula you want to use to solve any problem. So think about what you're working with. The acid that we're working with was HCl. And hydrochloric acid has how many hydrogens? You're right, it has 1. And what is the molarity of it? We don't know. That's what we're trying to solve for. So that is our unknown variable. And how much of the acid did I use? That we definitely do know, 50 milliliters. Okay, we're gonna do the same with the base. Think about what we know. We have 11 milliliters of 3 molar magnesium hydroxide. Okay, so the base magnesium hydroxide, you look at that formula, how many hydroxides does it have? 2, very good. And the molarity was given to us, it's 3.0 molar. And the volume we determined experimentally, we saw how much we added before the indicator changed, and that was 11 milliliters. All right, well, we have everything we need. We just need to plug it into the formula and solve. So we have 1 times the molarity of the acid, which is what we don't know, times the volume of the acid, which was 50 mLs. This is equal to the number of hydroxides. Now you'll notice this is how we're keeping it in proportion, because a neutralization reaction happens between the hydrogen and the hydroxide. So I have 2 hydroxides being contributed from each and every magnesium hydroxide that's in solution. So this keeps it in proportion. So instead of doing the actual stoichiometry, it's actually taking care of it in the formula for you. So we have 2 hydroxides, so I put a 2 there, as that's how many we have in the formula. The molarity of the base was 3.0 molar, and we used 11 milliliters. So now we just need to solve. Okay, so 1 times our unknown times 50, so I have whatever the molarity of the acid is, times 50 milliliters is equal to 2 times 3 times 11, so 2 times 3 is 6 times 11, 66 moles times milliliters. So how do I get that variable by itself, right? I divide by 50 mLs, and what I do to one side, we do to the other. So the molarity of the acid is 66 divided by 50. I am going to put the calculator out. Okay, that gives us 1.32. And look, milliliters cancel, you're left in molarity, which totally makes sense because that's what you're solving for, right? You want the concentration of the hydrochloric acid. So the concentration of HCl is equal to 1.32. Now, we do need to look at sig figs. Again, you don't look at the OH and H because that's not really a measurement, right? Like we are all going to count the same amount. The measurements come from here. So 3.0 would be 2 sig figs. 50.00 would be 3. 11 would be 2. 3.0 would be 2. Okay, so our lowest amount is 2 sig figs. So this is going to be 1.3 molar HCl. All right, so let's try this word problem. We want to know what is the concentration of the strontium hydroxide when 4.88 milliliters of a 0.1 molar hydrobromic acid is titrated with the 25 milliliters of strontium hydroxide. All right, I want you to think about the steps we just did. Think about your variables. So what's the acid here? That's the HBr. How many hydrogens? 1. What's the molarity of it? In this case, we do know the molarity of the acid is 0.100 molar. What's the volume? How much of it are we using? Well, it took 4.88 milliliters. That's how much it took to neutralize that base. Okay, so let's take a look at the base. The base is the strontium hydroxide. And if you look at that formula, how many hydroxides do we have? 2. Okay. And the molarity, well, the molarity is a fancy way of saying the concentration. That's our unknown. That's what we're solving for. So that's what we're going to solve for. And how much of it did we use? So what's the concentration of the strontium hydroxide when 4.88 mLs of 0.1 molar HBr, so that's the acid, is titrated with 25 mLs of strontium hydroxide? So we used 25 milliliters of that base. So now we have the stuff we need. We just need to plug it into that formula. So 1 times the molarity of the acid, which is 0.100 molar, times the volume, which is 4.88 milliliters. All right, that is equal to the number of hydroxides, which is 2. We don't know the molarity of the base, times the volume of it, which is 25 mLs. And I'm going to cut off some of those sig figs so I can put this on my screen. All right, so let's start to solve. Okay, so 0.488 molarity times milliliters is equal to 50 milliliters times molarity. And so, I'm sorry, the molarity of the base. So how do I get my unknown by itself? We're going to divide by 50 mLs on that side, and what we do to one side, we will do to the other. And so we get 0.00976. You'll notice milliliters cancels, it's molarity. Hey, that's what you were solving for, awesome. And the last thing we'll look for are sig figs. So if we go back and look in this problem, 4.88 is 3, 0.100 is 3, 25 is 4, the least amount we have is 3, so I can actually leave this exactly as is. So 0.00976 molar is our concentration of strontium hydroxide. All right, I hope this was helpful. Reach out if you need anything.